So we continue working with the interval of convergence and radius of convergence. This is example 2. One more time you apply the ratio test. Absolute value x n plus 1 divided by n plus 1 squared times reciprocal n squared divided by x to the n power. This is equivalent, limited, when the n approaches to infinity of n over n plus 1 square of and absolute value x, because x plus 1 divided by x to the n power is just 1x. Okay, es obvio que this limit is equal 1. And absolute value do not depending of m. Now the answer again is absolute value x. Absolute value x is less than 1, the criteria of convergence. Therefore, the solution of this inequality is in between -1 and +1. But I need to verification the endpoint in this case. For example, at x equal 1, now a series, my numerical series associated with this idea is this. 1 here, 1 squared is 1 over m squared. This is obvious que es convergent. It's convergent by p-test because p is 2, que is greater than 1. Now, suppose -1. The series is -1 squared over n squared. This is a alternating test, alternating series using alternating test determines its convergence of the range. It's obvious it's convergent because it's decreasing. And the limit when the n approaches to infinity of b sub k, que es n squared is 0. Entonces eso also converge by alternating test. So in this example, the interval of convergence includes both endpoints equal. So the interval of convergence is using interval notation, bracket, -1, +1. And the radius of convergence is obviously 1 because the center is in 0, and in between -1 and +1, center is 0, the radius of convergence is 1. Super. Okay, example 3. Again, determine the interval of convergence and the radius of convergence. One more time, you apply the ratio test. Absolute value x to the n plus 1 divided by n plus 1 factorial times reciprocal n factorial divided by x to the n. This is the limit when the n approaches to infinity. We have here n plus 1 factorial, n plus 1 factorial is n plus 1 times n factorial. N factorial is cancelled, so stay only 1 over n plus 1 times x, or actual value x, no? Because again, the same situation, que is n plus 1 divided by n x to the m is just 1x. And this limit is 0. Is 0, and 0 times any value is always 0, and 0 is always less than 1. That means this series always converges independent of the value of the x. So the interval of convergence is equal or real number from negative infinity to positive infinity. And the radius of convergence is infinity. This is nice. This series converges always to the any value, independent, regardless the value of the x. The sum is another problem, more complicated, que we discussing after. But the idea today is determine the interval convergence and radial convergence. This example 4 is another example to determine interval of convergence and radial convergence. The only new situation que bring me this example is that the center is located at x equal -3 here, -3. Okay, but again, you apply the ratio test, limited, and the k approaching to infinity of actual value is x plus 3 raised to the k plus 1 divided by x plus 3 raised to the k. This is obvious. Okay, with simplification, like the actual value x plus 3, because x plus 3 raised to the k plus 1 divided by x plus 3 raised to the k is only 1x plus 3, and this is less than 1. This expression do not depend of k. Therefore, the inequality we have in this moment is x plus 3 less than 1. Okay, it's equivalent to say x plus 3 less than -1 positive 1. Subtracting 3 is -4 less than x less than -2. This is the potential interval of convergence. But I need to verification the endpoint. Let me see. Suppose now at x endpoint -4. The series now will lie like that. K from 0 to infinity. I'm plugging in -4 here. There's -4 and +3 is -1. Es obvio que es alternating, but completely diverging, because never decreasing, diverging. For x equal -2, the series is -2 here is 1. 1 to the k power is 1 plus 1 plus 1. Again, diverge. Then the representation of the interval of convergence look like that. It's all real number. This is -4, -3, and -2. And the interval of convergence is in between -4 and -2. Do not include the endpoint, and the center is located in -3. Therefore, the interval of convergence is parenthesis -4, -2, and the radius of convergence is the distance from the center to both endpoints, K1. Super.